Hi there, welcome to Unit C for your summer work here. This is on expressions, equations, and inequalities. So three big topics here just to kind of make sure you got them in place because you have to be able to work with expressions, equations, and inequalities at all times in both Integrated Math 1 this year, Integrated Math 2, and moving on. You just have to be very comfortable with how to work with different types of equations and expressions. So today's lesson is actually going to I'm going to talk about three different things. I'm going to talk about how to simplify algebraic expressions, which is what your homework is about here. But I'm also going to include within that then also a little chat about the distributive property, which you're going to have to just have a good recall of and use when we start talking more about expressions and equations later on, as well as what we do when we're actually solving algebraic expressions, which is something that your homework doesn't have you do, but I want to make sure you know what to do. But in order to do that algebraic expressions and kind of get some solutions and plugging things in, you have to be able to use distributive property as well, and you have to be able to know how to hook things up together by simplifying them to begin with. So let's start here real quickly with simplifying algebraic expressions. So when a plus or minus separates an algebraic expression into parts, each part is called a term. Okay, the numerical factor of a term that contains a variable is called the coefficient of the variable. A term without a variable is called a constant. Like terms contain the same variables into the same powers, such as 3x squared and 2x squared. So we have different things, right? We have the terms, which might be something like a 2x, right, is a term there. The number in front of that is the coefficient, and the number here, the letter, is what's referred to as our variable. Now, if they have the same variable, okay, so 2x and 3x, then we would say that they are like terms. If it had a 2x, 3x, and 4y, we would say that those are not like, they're unlike terms, okay? And they do talk about the same powers. So the power means here, like in this case, here's this to the first power, it's the same. If this was to the second power, then those are not alike. So keep that in mind as you move further here, okay? Just very important there. We have our coefficient and our variable. If the variables are the same, we would call them like terms. Even if it's an exponent, as long as it's the same, these are alike. If, however, we had 3x squared and 4x to the fourth, these are unlike terms. And that's important because you can group things together and combine them together if they are alike. If they're unlike, you can't do that. Okay? So in this first example here, it says to identify the terms, like terms, coefficients, and constants in the expression 7x minus 5 plus x minus 3x. Okay, so it's sometimes helpful if you take a look at things with different colors. All right, again, eventually you can do it. I do color sometimes I do like boxes, squares. So if you just have a pencil, I'll show you that in a second. But in this case here, I have a 7x, I have a x, and I'm going to just circle the plus sign because it's kind of, I think, of it being positive. Here I have a 3x, and I think of that being add the opposite. So I have a 3x, so like a negative 3x there. Those are all of my like terms in this problem here. And then I have a constant, or a constant, which is the negative 5, right? And so that's by itself there. So in this case, I could combine things that are like terms. In this case, I have a 7x and a 1x and a negative 3x there. They're not asking you to do anything, they just want you to identify them there. So it says the terms are 7x, negative 5x, and negative 3x. The like terms are 7x, x, and negative 3x. The coefficients are the numbers in front, 7, and in this case here, in front of the x is actually a 1, so keep that in mind. And then in front of there's a negative 3, the constant's a 5. If I was to then do the next part here, which is write it in simplest form, that means I'm going to take these and combine them together. So I can combine the like terms. 7 plus 1 is 8, minus 3 becomes 5, and I keep the variable the same. And then my constant has no variable. I just keep it what it is, which is minus 5. So I could write that like that and keep it in simplest form just like so. That's how you take an algebraic expression and put it into simplest form. And we see that here down in this sample right here. Here I have a 5x and a 3x. Because the variables are the same, x and x, they are like terms. That means I can simply combine them. 5x plus 3x, well, think about 5 plus 3 is simply 8, and I keep the variable exactly the same. In this case here, they show you using the distributive property to do that there, which is fine. What they're saying is that this becomes, let's take the x out of both of these here, and we'll put the 5 plus the 3 in order to add together. So it's doing almost the opposite of distributive property. We're saying because this is 5 times x is 5x, 5 times 3 is 3x, which is how you get there. Alright, so that's one way of simplifying it. Another way here we can see, and I'll do it with how I do it without colors. I have my m's, I have a negative m there, I have a positive 6m here, and then over here you can see I have my constants, which might be there. So I can do circles for the m's and triangles for the other ones. That helps me sometimes too if I don't have colors. So I'm going to combine my circle ones. Negative 2, positive 6. 6 minus 2 is 4. And I keep my variable. And here I have a 5 and a minus 3. 5 minus 3 is 2. And so I can then simplify it like so. This is how we simplify things just like that. A couple examples. Okay, so again, negative 4, 2y, here's a minus 3. I can combine these ones. So negative 4 and a positive 2. The signs are different. I find the difference. 4 minus 2 is 2, and keep the greater absolute value sign, which is negative. So negative 2y, and then this coefficient just stays as negative 3. Over here, I have a negative 5g, positive g, and this is again add the opposite, a negative 1g. Again, think of it as a 1 there so you know what to do with it. So that's my coefficient in front of there. So negative 5 plus 2, and if you think about it, that number line there, right? So here's negative 5. I'm going to add 2, which means 4. I'm right here at negative 3, 1, 2. But now I'm going to subtract 1, so I go back here, and I'm at negative 4. Okay? So now I have negative 4g, and then that stays by itself right there. Okay, so that's kind of what you're doing with the homework part here. Let's just quickly look over distributive property once again. Distributive property means that I can take a number outside of the parentheses here, and I'm going to distribute. Think about passing things out. That's distributing. I'm going to multiply the 5 times the 3, and then I'm going to multiply the 5 times the x, and then 5 times the 3. This becomes 5x plus 5 times 3, or 5x plus 15. So that's how we distribute that there. Be careful when you distribute that you make sure you're keeping your signs correct. 9 times 4 is indeed 36x. That's great. But I also have 9 times a minus y. I could think of it as adding a negative, but that's going to be minus 9y. So it becomes add a negative 9y, and I can rewrite that then as negative 9y. So just be careful when you're distributing to make sure you pay attention to the signs there as you go through things. Sometimes one of the hardest things to do is kids forget to multiply. Let's say I had negative 2, and then I had inside of here, let's go with 3x minus 4. This is an example of one that kids struggle distributing because of all the signs. Well, again, think about this as this way. This is negative 2 times a positive 3. A negative times a positive is a negative. Well, 2 times 3 is 6, and I keep the x. That's okay. But here, what do I have? I have a negative times a negative becomes a positive. 2 times 2 is 4. So be careful with your signs when you do the distributive property there. If you have to start evaluating them, which you'll do later on, that simply means to take the variable, the value of the variable they give you, and plug that into the equation and solve for that problem there. So again, in the example here, you can see they take the 8 and they plug that in for x. So we have 6 times 8, which is 48, and we subtract 7, and get 41. So you're replacing things there, but again, watch those signs and be very careful. So if I was to come down here, I have 3 times AC. This becomes 3 times A is 4 times C is 7. And I multiply across, and I have just a big old number there. 3 times 4 is 12 times 7 is going to be 84, and I have just a big number there. If I have 5 to b squared, that means it's 5 times, in this case, b cubed. B cubed is b times b times b, or 2 times 2 times 2, right? That's what's happening with the b squared. So I have a lot. 5 times 2 is 10, times 2 is 20, times 2 is 40, and I move on. So lots of things you have to do within that when you're working with different expressions. Okay, I'm going to pause there, and then I'll start on your homework. Again, your homework is just essentially this part here, working with expressions and combining them, not just identifying them, but combining them there. There is some identification in the first part for the terms, coefficients, constants, but then expressing them in the simplest form is really what the homework is today. But I wanted to make sure you had some spot to come back to and look at distributive and expressions. Okay, see you in a bit after you try your homework. Alright, so today's homework here is pretty basic, simplifying algebraic expressions. They begin by saying identify the terms, the like terms, the coefficients, and the constants. So in this case here, our terms are going to be 6y, this is going to be a -4, and a y. Our like terms, our LTs, are going to be the 6y and the y. Our coefficients are the numbers in front, which is the 6, and in this case here, a 1. And then our constants, in this case here, is the -4. So if you're looking at the terms, that's what that looks like there. Here, in this case here, our terms are -12, 5g, 8, and -1g. Those are our terms. Okay, our coefficients are -12, 5, and the 1. Those are our coefficients. Our constants are right here at the 8. Oh, sorry, and I missed our like terms. Our like terms, in this case here, are going to be the, I can do square, the h, it has no like term, I'm sorry, no like term. So h would be there, we'd say that's h, and then we could do a g and a g. So our like terms are actually the 5g and the -1g. Those are our like terms. Those are the ones you can combine. Okay, number 5. We would say our terms are 8a, b, -3a, and 4b. Our like terms, well, the a's go together, and the b's go together. Coefficients are going to be 8, 1, -3, and 4. In this case here, there are no constants. Okay? So that's the idea for how you label those, tag them there, simple as that. If you went ahead and simplified it, which you didn't have to, this one for example, we'd have the 8a and the -3a. 8 minus 3 is 5a, and 1b plus 4b is 5b. Okay? At some point, they might want you to reduce that even more, simplify it even more, which would be like using distributive property, recognizing they both have 5 in there. So if I took a 5 out, kind of, I think of like sucking a 5 out of this one and that one, and writing it as 5 times a times b, I could rewrite it that way using kind of the opposite of distributing, because if I distribute the 5 through, I get 5a, 5b. That's something to think about there that you might use from time to time, but not required. Okay, let's take a look at your odd ones here. Simplify each expression. So first thing I'm going to do is kind of group my like terms. I have a -8q and a +5q. -8, +5 works out to a -3q. And then I have here a 6 minus 3, and 6 minus 3 is 3. This is an example where I could pull it out, but I'm not going to. I'll just leave it just like that. No reason to mess around with it. Okay, number 9. This is why we talked about the distributive property in our lesson, right? I need to distribute first of all so I can work on this. So 2a is 2a, Now I have a negative 5 times a. That becomes negative 5a. Here I have negative 5 times 1, which is simply negative 5. Now I can group my like terms, 2a minus 5a, or I can think about it as adding a negative, right, just like so. So negative 5a, positive 2a, find the difference. 5 minus 2 is 3, the greater absolute value is a negative, so it stays negative, and the constant's by itself, so negative 3a minus 5. Number 9. Okay, I'm going to rewrite this one here. This becomes a 9. Zoom in a little bit because I'm getting tiny. So I have 9 there. I'm going to rewrite this as negative 1t. So just remember that's a 1 there. I'm going to distribute here. Negative 3 times t is minus 3t. And negative 3 times a positive 3 is a negative 9. Okay. So my like terms, I have a minus 1t and a minus 3t. So I'm going to add a negative, the signs are the same, so I find the sum and keep the sign the same. 3 plus 1 is 4, keep this sign the same as negative, so that becomes negative 4t. And then I have 9 minus 9, which is 0, so I'm left with just negative 4t. Alright, number 13. Alright, nothing to distribute, so I find my like terms. 2m plus a negative 12m, sorry, minus a negative 2m, and then I have a 9 and a negative 16. So 12 minus 2 is 10m, and negative 16 and a positive 9, again I think of this adding the opposite. So the signs are different. I find the difference. 16 minus 9 is 7. And keep the greater absolute value sign, which is negative. So 10m minus 7. 15. Remember these are all ones. 1, 1, 1, 1, 1. And 1 plus 1 plus 1 plus 1 plus 1 is 5r. 5r. Okay, that's very different from if I had r times r times r times r times r, because that's multiplying, and if I had multiplying, that would be r cubed, or sorry, r to the 5th. All right, so we'll get that another time. That'll be a whole other lesson there, so don't do that. This is 5r. We're just adding them up. 17. All right, rewrite this. We have, first of all, negative 14y. Easy there. Distribute. Plus 12x, distribute plus 12, y, and then minus 12x. Now I'm going to group my like terms, negative 14y and 12y. 14 plus 12 equals 20, oops, that's negative 14, sorry. So signs are different, find the difference. 14 minus 12 is 2, greatest absolute value is negative, so keep negative 2y. And then I have 12x minus 12x, so just 0. So we keep it there, negative 2y. Number 19, I'm going to have to distribute here. Negative 5 times c is negative 5c. Negative 5 times d is negative 5d. And then we have negative 4d plus 5c minus d. If I want to rewrite all these, I could. That's fine. So this becomes add a negative 5d, add a negative 4d, add a negative 1d. So grouping terms, negative 5c, positive 5c. Those cancel out. 5 minus 5 is 0. So now I have negative 5 plus negative 4 plus negative 1. So signs are the same. Find the sum. 5 plus 4 is 9, plus 1 is 10. Keep the sign the same. Negative 10d. 21. I have negative, I'm going to write this as 1p plus 1q plus 2 times p is 2p. 2 times q is 2q. I'm going to rewrite this as add a negative p, a 1p, and then I'm going to add a negative 1q. Okay? So, a lot of craziness here. So we have p's, negative 1p, 2p, negative 1p there. I have q's. I have 1q, 2q, and negative q. So in this case here, my 1q and negative q becomes 0. And then over here, I have a -1 and a -1, which is -2, plus 2 become 0. So all I'm left with then is this guy right there for 2q as a solution. All right, our last one for today, we have -12z plus 4 times z is 4z. 4 times -9 is -36 plus 30 plus z, and it's a 1z. So -12 plus 4, I have 12z, 4z, 1z. So -12 plus 4 is a -8, plus 1 more is a -7z, -7z, and then -36, positive 30, signs are different, find the difference, which is, I'm going to write right here, -7z, which is 6, and the greater absolute value is going to be the negative, so -6. So -7z minus 6. Alright, I'm going to leave it at that one. If you did the word problem, fantastic. And that's it for today. We will see you next time.